Okay, so lads, this is a topic about area and volume, and what we're going to do is we're going to look at different types of shapes, okay? And they're all in Text and Test 2, page 138 and 139, so in your maths book, all right? We're just going to look at the different shapes to help you revise. So the first one I'm looking at is this one here, and we're asked to find the volume and the total surface area. What we must actually probably realize is, first of all, is to identify the shape we have. And the shape we have is that of a prism. A prism is a solid object that has a cross section that is the same throughout the whole shape. So for example here, if I want to take the front of this, right there now, just highlight the cross section of this all the way across the shape. Like if that was a slice of cheese, right, or a chunk of cheese, and let's say I cut here, the same shape would be on the inside. That triangular would be there. So that's what defines it as a prism. But what you also could actually recognize here is that if you had another chunk of cheese, if you thought that was a chunk of cheese, if you put another chunk of cheese and you actually just slapped the two chunk of cheeses together, what would you have now? You'd have a cuboid, wouldn't you? It's not a cube, it's a cuboid because you've got rectangular faces around the sides. Okay, so I'm just going to remove that there now. Sometimes it's very good, lads, just to get an idea of the shape you have first of all, before you get stuck in. The volume. So to get the volume of this, I'm going to go length by width by height, as you would have for a cuboid. So for volume, I'm just going to take this down this way first of all. So 8 multiplied by 6 multiplied by 4. So you're going to do that out first, and you can calculate it there yourselves and tell us what you get. So I'm getting 192, and that would be the volume of a cuboid. But because there's two of them in a cuboid, all I do is I'm going to divide by 2. That's 96. So the volume of this cuboid, or sorry, of this prism is 96 cm cubed. That's that one done. And now I'm going to do total surface area. So for the total surface area, I must get the area of every surface. So total surface area. Right, I have 1, 2, 3, 4, 5. You have to count all the faces first of all. So this one, I've got one underneath that I can't see, but I'm going to put in there now. 2. I've got this rectangular face in front. 3. I've got one going down the back. 4. And I've got the other triangle at the opposing side. So if I'm going to start with the triangle ones, well, that's a right angle triangle, isn't it? So I'm just going to go half the base by the perpendicular height, because that's my formula for the area of a triangle that has a right angle in the corner, which it does, look there. Half 6 by 8. And I get 24. But lads, I'm going to double that because I've got 2 triangles at either side. So that's back to 48 again. That's the first one I'm going to use. Now I'm going to do the back one. Excuse me. The back one is in the shape of a rectangle. I can see it's 8 centimeters in height and 4 centimeters in width. So 8 by 4 is 32. That's grand. And I'm going to circle that because I'm going to use that. The front face, that rectangular face facing us, is a 10 by 4 rectangle. So 10 by 4 is 40. Okay, and I'm circling that. And then the base of this prism is 6 by 4, another rectangle, which is 24. And I've got them all now, because even though I've circled 4 bubbles, remember there's 2 triangles, so I counted that. I took account of that at the start. So 48 plus 32 plus 40 plus 24, and you get 144 centimeters squared, because we're talking area. The total surface area of this shape is 144. And now we're going to talk about the next one, and the question for this one is in the book. we're looking at, first of all, I suppose we're going to look at the shape. So we have, it looked like a bit of a circle. It doesn't look like it's a chunk taken out of a circle. It could be like even a pizza, a slice of pizza. But really, I suppose what we're talking about in terms of shape here is that it's a sector. Now, the question in the book on page 138 asks us, taking pi to be 3.14, find the area of the sector. So pi equals 3.14, find the area of the sector. So area of sector, that's what we're asked for. This time I'm going to say, to get the area of the sector, I need to know that it's the angle over the total angle in a circle, which is 360, multiplied by pi r squared. And what I'm going to get here is 120 over 360 multiplied by pi is 3.14. Sometimes it's pi is 22 over 7. But if they say to use 3.14, use 3.14. And the radius is 6 squared. And then you just throw all of that into your calculator, lads. Make sure to press the fraction button for the 120 over 360. And then 6 squared. And you're going to get an answer of 37.68 centimetres squared. This 37.68 centimetres squared represents the area of the sector. Can we just be careful, lads, about one thing here, please? Like another alternative is like, you could have said, well, I'll get the area of a circle, pi r squared, and you get that area, and then say, well, hold on now, I don't have a full circle. I've only got, you could break that down to a fraction, couldn't you? Like, I'll just actually write down here, 120 over 360. You could say 4 into that, got 3 times. And then you could say, oh, that's what, I've only got 1/3 of a circle, so I could divide by 3. So you get the area of the circle and divide by 3. That's absolutely fine. But I just find, what I love about this formula is that you just throw it all in and it's done. That's that one. The next one on question 3, page 138, they ask us to find the area of the given parallelogram. Now, to be honest, look, if it came up in the summer exam, it might just say find H, and they won't say anything but find the area of the parallelogram. So you would have to think, geez, how am I going to find it? So let's just say this question just said find H. So I'll write up here, find H. You always use the information that's in front of you. Like, they don't throw in them numbers for the laugh. They're there for a reason. They're there to be used. And most of the times you'll use all the numbers. So then you just look at what could you use. Think about what we've learned about the parallelogram. So we've learned, we've done about area. We've done about, you can, oh sure, perimeter, you just add up all the sides. So with the parallelogram, it's base multiplied by the height, okay? And in fact, it's not any height, it's your perpendicular height. So I'm going to say the area of the parallelogram is base multiplied by the perpendicular height. Now that's the sign for perpendicular. Okay, so what we're going to do then is I'm going to say, well, I can't use 8 centimetres because I don't know H. Look, I don't know the one I'm writing there in blue, but I do know, or do I? Well, she's a do actually. I do, don't I? I was reading it wrong, sorry. Yes, we know the base is 8 centimetres and we know the perpendicular height is 9 centimetres. So what I can't use is the 10 centimetres one straight off because I don't know that one. Look, the perpendicular height there. So you just look at your angle there. My angle there is 90 degrees and it's going straight up. So what we do is we say 8 multiplied by 9 and that gives me 72 centimetres squared. Well, this is the area of a parallelogram. So I know the area of the parallelogram now and all I need to do is find H. So to find H, I'm now going to, I have to use the corresponding base that goes with it. That's 10 in H. So I'm going to say 10 multiplied by some number will also give me 72 because I have the area now. Well, then H is going to be H equals 72. Bring 10 over the equal sign, it becomes divide 70 because it's multiplied by on the left hand side, divided by 10. H equals 7.2 centimetres. Find H. I have found H. H is 7.2 centimetres. We're now looking at the top cuboid. It's on page 139. It's question 7. And let's say, for example, they said find the surface area of the prism. Okay, again, this is a prism and it's a more easier one to look. You might think, God, how, like, but she said it's a cuboid. Yeah, but sure, it's made up of prisms. It has the properties of a prism as well. So one of the properties of a prism is that if you take one side of it, so let's say I take this one here, right? The rectangular face in front. If I cut, let's say I have a knife. Say, I'm not good at the old art now, but anyway. So let's say that's supposed to be a knife going back. So let's say that's a block of cheese again and I cut that way down. Let's say I cut straight down that way. I would find that somewhere along here, I'll take off a chunk, that the same area is going all the way across. Or I could decide I could cut, say if I looked at this face. And again, if I cut this way, I could find that the same area is going all the way across. So that's all it means there. So what we're going to do is we're going to do the surface area, isn't it? Okay, so to get the area of a rectangle, you know from primary school that is going to be the length multiplied by the width. So if I take this one, so it's 3 multiplied by 2, so I'm going to go 3 multiplied by 2, which gives me 6 centimeters squared. Well, hold on a second. I've got, that's the front of it. The back of it is 3 multiplied by 2 as well, isn't it? So now I'm going to say, well, that's multiplied, I'm going to times that by 2. I've got 12 centimeters squared. That's the front and the back done. Okay, so I'm just going to say on top in case you're wondering where all these are coming from. So front and back. I'll just change the colour of the pen. Up on top, I've got the top lid and I've got the bottom lid, if you want to call it a box or whatever. So going across, that's going to be 3 by 3, isn't it? So I'm going to go 3 by 3 and that gives me 9 centimeters squared. Going to double it and that's going to give me 18. I better start doing my bingo on this. Circle the 12, circle the 18 at the top. This is the, I'm going to say here, that's the top and bottom. Top and bottom. And now I just need to do the sides. I'll change again. So to do the sides, whoops. So do the sides are going to be 3 by 2 again, aren't they, going along? Just like the last one up on top. See up there, so it was 3 by 2, so 3 by 2 is 6, double that is 12. So all I do is add them up and I get 42, don't I? 12 plus 18 plus 12. So the total surface area is 42 centimeters squared because it's area. There we go. That's the total surface area. Then for the next one again, very similar again, if they asked you to get the volume of that box, by the way, lads, the volume of the box is, let's just write that down. So volume of a cuboid is length by width by height. Okay, so bring that down. So let's say they asked for the volume. Volume equals length by width if you want, or breadth by height. So if that was the case, I'd be saying 3 by 2, which equals 18 centimeters cubed. The volume of that cuboid or prism, whatever you want to call it, is 18 centimeters cubed. Okay, so that's that part done. And now we're going to roll on into this one here. Again, we've got a prism. It's a prism because if I decide to take a chunk off of one side, so if I take a chunk off the front part, just take all that away. If I decide to take a slice off this side, well, I know that triangle is going to go all the way back. So by definition, it has the same cross-sectional area going back, cross-section, because it's across the shape. Again, all we do here is, if you're asked on 139, if they said, in 139, they say that this is supposed to be a tent, and find the cost of the tent if each square metre of canvas costs $24.50. Okay, I don't really care about the further calculations coming. So they're saying here, find the cost of the canvas if each square metre. Lads, they speak about square metre for this. So this is supposed to be a tent. And they're talking about every square metre. If you went into Woodies and they told, oh, look, every square metre that you're going to buy for that canvas now is going to cost you $24.50. You use the clue here, the question. They didn't say find the area, find the volume. They just spoke about square metre. So you make that link then to say, well, what's that the unit for? Is that area or is that volume? And you know that's area. So that means, right, well, I must use the area formula. So, and to use the area formula is similar to what we did above. You would just be trying to find the area of the back, and you get the total surface area, don't I? So again, you have to look at the shape you have. This time the shape in the front is that of a triangle, and the right angle's in there, so I'm going to go half the base by the height, the perpendicular height